Hello everyone, my name is Mohanteja and in this video we're going to solve the second problem of top interview questions of the LeetCode. If you go into the LeetCode and if we can see top interview questions, these are the top 150 interview questions we are solving, and today we are going to solve the second problem of of that list, right? So this is the second problem, which is remove an element from an array, given array. Here is the problem statement: given an integer array nums and an integer value, and remove all the occurrence of the value in the nums in place, right? So as we discussed in the previous problem, that in place is like we should not take the new array. We need to change the current array to satisfy the condition. To get the output, we need to change the adjust the current array. We need to manipulate the current array so that it will get the desired output. So that's what the problem statement is asking, and here the order of the element may be changed. It's a plus. It's a plus for us. It makes us solving the problem very easily. So we're gonna use this condition. Although we're gonna preserve the order as well, I'm gonna tell you what the order means and what is not preserving it or maybe changing it. I'm gonna explain that. And then return the number of elements in the nums which are not equals to value, right? So we need to return the nums where the value should not be there. The value that was given, the integer value that was given in the problem statement, that should not be there in the nums in the given array. So that's the problem statement, and here we need to consider that the number of elements in the nums which are not equals to value will be k. So we just need to return the value of k. Here are the conditions. Change the array nums such that the first k elements of the nums contains the elements which are not equals to value. And the remaining elements of the nums are not as important as the size of the nums. So we just need to get the k number of values in that array, first k values in that array that are the output, but rest of the elements in that array will be ignored. So yeah, that's how we need to change. We need to change the array in such a way that first k element should not contain any value in it. So that's the condition that was given, and for this, look at the example. We're gonna look in one of the example here. The nums is 3, comma 2, comma 3, and the value is 3. So here we can see that the output we need to return is 2 in such a way that we need to change the array of nums as 2 comma 2. In the first two elements should be 2 comma 2, and we need to return the k value which is equals to 2, right? That's the output we need to return, and we need to change the nums, the array of nums, right? So that's the output we need to return it here. And for that, whenever we look at the problem, the first approach we will get into our mind is brute force. Obviously, most of us, we're gonna think about the problem in brute force way. Here also, we're gonna solve it in brute force because that's the first approach that came into my mind, which is like just going through every single element in the array and find the if it's matching with the given val. If it's matching with the given L, just remove that element from the nums. We'll remove that array and we'll get the final output, right? So I'm pretty sure most of us will get the same approach in our mind as soon as we see the problem. So first we're going to implement that, and then we're going to see what is the problem with that brute force, and what are the other optimized approaches we can take, right? There are a couple of optimized approaches. We're going to look into that after the brute force implementation, right? So first of all, how the brute force we're gonna do is we're gonna go into the loop into the entire array. While using while loop or for loop, we're gonna loop into the array, and we're gonna check if that element, right? Here first element is equal to val or not. If it's equal to val, then we're gonna remove that from the array, right? That's what we're gonna do simply. Let's just take I equals to 0 and k is equals to len of nums, right? The len of nums is the k. The reason we are taking the k value is because after removing the element, if we continue doing till the len of nums, then we're going to get the list index out of range because the length of the array will be reduced. If we remove an element from the array, the length of the element will be reduced. That's the reason why we are tracking the length of the array with the variable k here. So that's why we are taking k, and here while I is less than, instead of len of nums, we're gonna do with k here, and we're gonna check if nums of I equals to val, right? And if it's equal to val, we are gonna simply remove that. We're gonna remove the nums of I from that array, and then we're gonna reduce this, right? We're gonna reduce this k value with 1, so that as we are removing one element from the array, we need to reduce this from the k, so that here the condition will not get listed as out of range, right? So, or else if that if condition does not satisfy, we're gonna go into else condition, where we're just gonna increase the value of I with 1, right? And then we're gonna return k and see if it's, I think it's k minus 1, I believe. Okay, yeah, k, because I thought, all right, so here is the k, and if we submit and see, it's a brute force approach. As you can see, we are going through every single, yeah, runtime is giving 100%, but we need to consider here that in the LeetCode, we might get runtime 100% because of the server speed, or sometimes we might have test cases that does not calculate the worst case scenarios. But this brute force approach will take O and square times. Let me show you why. Right? Like if we calculate the time it's gonna take is here. If we are going to while loop at the worst case scenario, we are calculating until length of the array, right? We are calculating until length of the array. This is the worst case scenario. Here, the length of the array we are calculating is O of n times, right? And also here we are removing the element, which is also will take in the worst case scenario. The element is at the end. If the val if the array is at the end of the array, then the how the remove function works in any Python or C or C++, any language, the remove is very expensive. What it will do is it will go through the entire array, and it will try to find the first occurrence of that element, and it will remove that element, and it will pull that elements, like it will put that into the left. I mean, like it will, the end of the array, it will put it in the left side of that array, right? So that's how remove will work. It will go through the entire array, and it will in place the left side of that whatever the element that was found to the left of that. It will move one step to the left, right? That's how it's gonna take the time. So here the time is O and square. So it's very expensive. The remove function is very expensive. So that's why this brute force approach is very expensive here, right? That's the reason it's uh, it's very time taking. So how we can optimize this? Uh, there are a couple of ways we can optimize. For example, here you can see that we do not need to we just need to find the first k elements, and we do not need the last elements. What are the elements that are there in the array? So instead of removing them, removing is the just expensive part, right? So what we can do is we just gonna, whatever the in that place, whatever the value that was found, if we just replace that with some other element, like replace that with non-val value from that array, we can make it optimized, right? For example, here I will just put it in the comments, and here if we see, this is two pointer approach. The other approach, there is one more optimized approach where we can do the same thing, replacing the val value with some other element. Here, in this approach of the two pointer, what we're going to do is uh, we're going to start with 0 as well. And here len of nums, like previously we have done until len of nums. And what we do here is uh, instead of removing the element, what we can do is in that place we are removing nums of I, right? In this place we can insert nums of k, right? So that's what we can do here. Just insert in the nums of k, and yeah, we just insert in the nums of k and moving to the next element, next I value, right? Next I value, right? So I think it's the same. Rest of the code is the same. It remains the same. Now, if we run this, it should pretty much give the output. What we are just doing here, I think it's length of n minus one, right? K should be k minus one here because we are replacing the last element. Last element will be len of nums minus one. So that's what we are replacing. It should give the correct output. All right. So k minus 1 minus equals to 1. Plus equals to 1. Uh, k minus 1. Uh, all right. So the all right. So I think list of len of nums here we can, because the last of nums of len of nums is probably the len of nums starts with 0, right? So I think here if we take the previous number of that nums, it should work because we are just replacing the last element with that nums of I. And yeah, there you go, it works. So if let's submit this and see. And also if we let me, yeah, you can see that it's also giving 100% runtime. It's better than previous output. I mean previous approach that we do. Here we just here, because of this remove is just the expensive part here. That's why we are going through with this. Instead of using remove, we are just replacing with the last element, right? So although this is optimized, but this does not preserve the order. Order in the sense, for example, let me see in the description. Here you can see that 3, 2, 2, 3, right? 0, 1, 2, 3, right? So 2 comma 2 is the order, but whenever we are trying to, when we look into here, the order in the sense, if we are putting this 0 1 3 0 4, right, that's the, if we put that in this order, the output is in this order 0 1 3 0 4. That's the output, then the order is preserved. But you can see here the output is 0 1 4. The last element is going here. That's not preserving the order. The order is changing because the last element is coming to the front. That's not preserving the order. But we can try preserving the order in some other approach. Like we are seeing that from the back we are trying to put the element. Instead, from the front, if we replace the val with some other element from the front itself. For example, let me. Is this again is the same approach? Uh, Let me give 1 second. It's the same approach. It's the two pointer. Here also, even this is the two pointer, but we are reinforcing it. And this is we are trying to. This is also kind of brute forcing, but here we are not using the function of remove. Instead, we are trying to use the use linear time so that it will take linear time only while executing. And we are gonna take the same approach here as well, but instead of from the end, we are going to do it from the beginning. And yeah, it's the same while I is less than k. Or wait a second, I think it's while I is less than nums, because here the nums value is not changing at all. So we're gonna keep the len of nums value the same here. So if nums of I not equal to, right? If it's not equal to value, for example, we're gonna check 3 is equals to 3 or not. If it's equal to 3, we're gonna keep that as it is. And if we're gonna check if 2 is not equals to, because we are tracking the second pointer with the k, and we are not changing the k value here. Instead, we are, if, if it's not equals to value, we're not gonna change the k value here. Instead, we're gonna uh, if it's not equals to, let's just see, if it's not equals to val, then we're gonna put nums of k. Here the nums of k, for example, here the nums of k is 2. So what we're gonna do is we're gonna keep that value with nums of I. So basically what we're doing, if it's not 3, we're gonna keep that k value here, k pointer here, and we're gonna change the I pointer to the next one. If it's equal to val, then we're gonna replacing whatever the k pointer is, wherever the k pointer is, with the current value, because the k is keeping wherever the k is staying over the previous val function, val, wherever the val is in the nums, the k is staying at that pointer, right? So that's the reason why we are keeping that wherever it is. So we're gonna keep it like that. Then we're gonna increase the k value here only when if it's I think we need to increase I value everywhere. All right. Uh, if it's equal to value, then k should be increased. Um, all right. So I think yeah. All right. So we do not need to as value here. If it comes of I equal to value, then there is no need to change the k value. If it's not equals to value, then we need to change the k value to 1, so that the k will change whenever it's not equals to 1. If it's equals to val, then the k is going to stay over here until we find the non-val function, non-val value in the nums, right? So, and then we're gonna keep on increasing the I, all right, for every step, because we are doing it until the line of nums, right? So we can execute this. This will preserve the order. It's the same thing, but we are doing from the start. This is also the same thing we are doing from the back, and we are changing the missing value here. In the first approach, in the brute force, we are removing the missing value. But in the second approach, instead of removing the missing value, we are replacing the missing value with the last number. And in the third approach, we are replacing the missing value with the previous value, with the previous val index, right? With the previous val index, we are replacing that previous val index. We are tracking that previous val index, and we are replacing that with the current element, right? That's how we are taking the approach here. The order will be preserved because we are doing from the beginning, and we are just replacing the front, wherever the val function is, we are just replacing with the next non-val val value is we are replacing with the non-val value from the nums, right? So that's the approach we are following here. I hope you know. Let's see. Let's submit this and see if it's going well. Yeah, there you go. It's giving 100% runtime. Although we beat everyone within all the three approaches, but yet almost these two follow the same time, like O of n itself. You can see it's just running through the loop once of O of n. So this is also running through the loop of O of n. It's the same loop. Here we are following the same loop only. So yeah, almost pretty much they both have the same runtime, but just that this here we are not preserving the order because we are replacing the first the missing element, the value with the val with the last element, right? So that's why the order is not preserved. Here we are just replacing the non-val value with the next coming val, the index with the val, we are replacing with the next immediate non-val index, right? So that's how we are doing it. So that's it for this video. Hope you learn something from it. I think basically it's simply two pointer problem. This is just simply two-pointer problem. So I hope you understand how the two pointers works. We will just take the two pointers and we will track them in the particular array. So yeah, hope you learned something from it. Thank you.